Hi everyone, welcome to my channel. My name is Thirumavalavan Srinivasan. In this video, I will show you how to connect to an internal web application using AWS Verified Access without VPN. Before we dive into AWS Verified Access, let me quickly introduce about myself. My name is Thirumavalavan Srinivasan. I have over 20 years of IT industry experience. I'm also an AWS community builder, and these are the certifications that I have achieved in the past. And I'm also an ex AWS partner AIML Black Belt, and I'm also an ex AWS partner ambassador. I think that's enough introduction about me. Let's now quickly see about AWS Verified Access. AWS Verified Access provides secure access to corporate applications without a VPN, and it improves security posture by evaluating each access request in real time against predefined requirements. Verified access verifies each access request in real time and only connects users to the applications they are allowed to access, removing broad access to corporate applications and reducing the associated risks. To verify users against specific security requirements, Verified Access integrates with AWS and third-party security services to source information about identity, device security status, and location. And it delivers a seamless user experience through virtual access to corporate applications without a VPN, and defines a unique access policy for each application with conditions based on identity, data, and device posture. IT administrators can use verified access to author a set of policies that define a user's ability to access each application. Verified access also simplifies security operations by allowing administrators to efficiently set and monitor access policies, freeing time to update policies, respond to security and connectivity incidents, and audit for compliance standards. AWS Verified Access evaluates each application request from your users and allows access based on trust data sent by your chosen trust provider and the access policies that you create in Verified Access. When a user tries to access an application, Verified Access gets their data from the trust provider and evaluates it against the policies that you set for the application. Verified Access grants access to the requested application only if the user meets your specified security requirements. A trust provider is a service that sends information about users and devices, called trust data, to AWS Verified Access. Trust data may include attributes based on user identity, such as an email address or membership in the organization, like sales or HR organization, or device management information such as security patches or antivirus software version. Verified Access supports the following categories of trust providers. First, user identity. User identity is an identity provider service that stores and manages digital identities for users. Next, device management. A device management system for devices such as laptops, tablets, and smartphones. In this demo, we will use user identity based trust to provide access to the application. We will use Cognito as the user identity trust provider. Now let's see some of the features of the AWS Verified Access. 1. Number 1. Security. Using Verified Access, you can configure fine-grained access for your applications, ensuring that application access is granted only when users meet the specified security requirements. For example, user identity and device security status. Built on zero trust guiding principles, verified access validates every application request before granting access. Verified access also supports AWS WAF, helping you filter out common threats such as SQL injection and cross-site scripting. Next, user authentication. Verified access is seamlessly integrated with AWS IAM Identity Center, which allows end users to authenticate with SAML-based third-party identity providers. If you already have a custom identity provider solution that is OpenID Connect compatible, verified access can also authenticate users by directly connecting with your IDP. Device posture assessment. Verified access is integrated with the third-party device management services to provide additional security context. Therefore, you can additionally assess access attempts using the security and compliance state of the user's device. Personalized apps. Verified access passes signed identity context such as user alias to your applications. This helps you personalize your applications using this context, removing the need to re-authenticate the user at your application. The signed context also protects your applications in case verified access is accidentally disabled, as the application can reject the request if it doesn't receive the context. Group applications. With verified access, you can group applications with similar security needs. Each application within a group shares a global policy, achieving a minimum security bar for the entire group and removing the need to manage individual policies for each application. For example, you can group all dev applications and set a group-wide access policy, or like a HR or sales applications. Access logs. Verified access logs every access attempt so that you can quickly respond to security incidents and audit requests. Verified access supports delivery of these logs to Amazon S3, CloudWatch logs, and Amazon Kinesis Data Firehouse. Verified access supports the Open Cybersecurity Schema Framework (OCSF) logging format, making it easier for you to analyze logs using one of the supported security information and event management and observability providers. Next, let's see the use cases for AWS Verified Access. Secure distributed users. Verified access evaluates each request in real time against predefined security requirements to facilitate secure access to applications. Manage corporate application access. IT administrators can build a set of fine-grained access policies using security signal input like user identity and device security status. Use centralized access logs. Verified access evaluates access requests and logs request data, accelerating analysis of and response to security and connectivity incidents. Next, let's see the steps to configure AWS Verified Access. First, we need to create the Amazon Cognito user pool. In this demo, we are using Cognito as the identity trust provider. So first we need to create Cognito user pool. Next, we will create Cognito users that we can use to test the application later. We will create two HR users, one with an email address verified and the other with an email address that is not verified. Next, we need to create AWS Verified Access Trust Provider using Amazon Cognito. One of the key components of AWS Verified Access is the trust provider. A verified access trust provider is a service that manages user identities or device security state. Verified access works with both AWS and third-party trust providers. You must attach at least one trust provider to each verified access instance. You can attach a single identity trust provider and multiple device trust providers to each verified access instance. In this demo, we will configure Amazon Cognito as the verified access trust provider within the verified access console. Next, we need to create AWS Verified Access instance. A verified access instance is an AWS resource that evaluates application requests and grants access only when your security requirements are met. It also helps you organize your trust providers and verified access groups. Next, we need to create AWS Verified Access groups with basic policy. An AWS Verified Access group is a collection of verified access endpoints and a group-level verified access policy. Each endpoint within a group shares the verified access policy. AWS Verified Access policies enable you to protect access to your corporate applications hosted in AWS. They are written in Cedar, an AWS policy language. With verified access, you can express policies that use the trust data from the trust providers you configure, such as corporate identity providers and device security state providers. Verified access groups can be used to combine endpoints that have the same security requirements. This can help simplify policy administration by using one policy for the security needs of multiple applications. For example, you can group all HR applications together and set a group-wide access policy. You can then use this policy to define a common set of minimum security requirements for all HR applications. This approach helps to simplify policy administration. Next, we need to create AWS Verified Access endpoint. In order to create a verified access endpoint, you need a public domain name and a SSL or TLS certificate. I have already registered a public domain in Amazon Route 53. I have also created a public hosted zone. I will show it to you later in Amazon Route 53 console. I will also walk you through the process to create or request SSL certificate later in the demo. Next, we need to update Amazon Route 53. In this step, to associate the verified access endpoint domain with Amazon Route 53 hosted zone record for access through a well-known and easy to remember application domain name. We need to add a CNAME for this in Amazon Route 53 hosted zone. The final step is to test the application. In this section, we will validate the setup we have done so far with Amazon Verified Access to provide zero trust access to our application, that is HR application, using the user identity trust with Cognito as the trust provider. And this is the architecture for internal web application. I will show you in the demo and I'll walk you through how to create this architecture. In this, it's very simple. I have an VPC and I have two availability zone and I created two private subnet, and I have created an internal application load balancer, and I have also created Lambda, and Lambda is going to serve as the compute environment, and we are going to host our simple HR application website in Lambda. And I will walk you through in the console like how to create this architecture. And next, let's see the architecture for AWS Verified Access. This is the architecture for AWS Verified Access. So if you remember from the previous slide, we already have an internal application load balancer, and we have Lambda, and here we are going to configure AWS Verified Access, and we need Route 53 and Amazon Cognito and AWS Certificate Manager. And once we I will walk you through in the AWS console like how we can configure AWS Verified Access. I think that's enough theory. Let's go to AWS Management Console, and I'll walk you through the process. Great. I have now connected to the AWS Management Console. I'm at the console home. First, we are going to implement this architecture, that is internal web application. So for this we need to we'll have to create a VPC, and then we'll create Lambda and application load balancer. So let's go to VPC first and create a VPC. Currently I have only one VPC, that is the default VPC. So let's go ahead and create one, and let's create VPC and more, and let me name it as Verified Access Demo VPC. And I'm going to use the IPv4 CIDR block as 10.0.0.0/16, and I'm not going to have any IPv6. And the number of availability zones, we need 2. If you remember, in our architecture we have 2 availability zone, and we don't need any public subnets, so I'll select 0. And the number of private subnets, we need only 2, and we don't need any NAT gateways, and we also don't need any VPC endpoints for this demo, and everything else is good. So if you see, this is the architecture it's gonna create. So this is the VPC, and we are gonna have 2 subnets and 2 availability zone, that is on US East 1A and US East 1B, and then it's gonna create the route table and everything. So yeah, these are the architecture that we are going to create. So let's go ahead and create the VPC, and this shouldn't take much time, and it will be really quick. So yeah, the VPC is created now. And if you go back here, and you can see 2 VPCs. This is the default VPC, that is in 172.31.0.0/16 network, and Verified Access Demo VPC is the one that we have created now. And if you go to subnets, you can see the 2 subnets: Verified Access Demo subnet private 1 and private 2 on US East 1A and US East 1B availability zone. It's created. I think that's good. So we have created the VPC. Now let's go ahead and create a Lambda function. So let's go back to console home and select Lambda. And if you don't have it in the recently visited tab, you can search and get that. I'm in the Lambda console now. Let's go ahead and create function. So I'm going to author from scratch. I'm going to name this one as my HR web app. I'm going to name it as my HR web app Lambda function. So I'm going to do it on Python. And for that execution role, so let me go ahead and create a new role with basic Lambda permissions. So it will automatically be created. We don't have to create. So I'm just going to create the function. And here it's created. And for the Lambda function code, I'm going to replace this one with a simple web page. So if you remember, yeah, just this is a simple web page, and I'm just having a HTML file, and it says like, title as welcome to HR application, and then the body is that welcome to the HR application. So this is the simple HTML page that we are going to host in Lambda. And let's deploy this one. Yep, it's done. And let's go and change some of the properties. We need to go to configuration and go to general configuration, and I'm going to edit and then set the timeout. We don't need 5 minutes, but I'm just not to be in safer side, I'm just going to change it to 5 minutes. And I'm not going to change the memory and everything because it's just a basic web page. I'm going to save this one. It's done. And next we can go to the permissions. Yeah, that's fine here. And yeah, this looks okay for now. And let's go ahead and create the application load balancer. For that, need to go to EC2 and go to load balancers, and we need to create the load balancer, and I'm going to create application load balancer. I'm going to name it as my application load balancer for Lambda, and it's going to be internal. If you remember, in our architecture we are going to have an internal application load balancer, and IP address type is IPv4, and network mappings, I'm going to select verified access demo VPC, and I'm going to select both the availability zone and the subnets in it. So I have only one subnet in each availability zone. It's both a private subnet. It doesn't have route to the internet. We don't have any internet gateway or anything. So we got that selected, and for the security groups, we need to create a new security group. I'm going to create a new security group. The name is my application load balancer. Security group, and for the description I'm going to say like allow HTTP traffic from 10.0.0/16. So we are going to basically do that ingress from our VPC, ingress traffic, that's incoming traffic. We need to allow that the HTTP traffic from within the VPC. And for the VPC, again select verified access demo VPC, and now set the rule ingress, and I'm going to do HTTP and we are going to do it, allow it from 10.0.0. And select this one. We are allowing HTTP traffic and protocol TCP protocol port 80 from our VPC, that is 10.0.0.0/16. And we are not going to change anything in the outbound rules, and everything looks good. Let's go ahead and create the security group. And now let's go back to here, and application load balancer creation wizard, and I can refresh it here, and my ALB security group is listed. I'll unselect the default one here. For the listeners and routing, we need a target group, so let's create that here. We could have created already, but here this process, the application load balancer creation, we can create it here from here. Click on this one, and we're going to select Lambda function, and for the target group name, I'm going to name it as my target group for Lambda function. I'm not going to do any health check or anything here. I'm going to go next, and to select the Lambda function, I'm going to select my Lambda, my HR web app Lambda function that we created earlier, and we are going to select the latest version here and create the target group. So the target group is created now. Let's go back to application load balancer creation wizard, and let's refresh the page. And yeah, my target group for Lambda function is listed. We'll select that one, and everything else looks good. Let's go ahead and review it. And so this is my application load balancer for Lambda, and it's internal one, and we are having IPv4. We have created a security group that allows ingress traffic from within the VPC for HTTP, and we have selected our verified access demo VPC, and then selected both the subnets in US East 1A and US East 1B availability zone, and we have created listener routing for HTTP on port 80, and then we also created the target group for the Lambda function, and we have selected the Lambda function that we have created earlier. Everything looks good. Let's go ahead and create the load balancer, and this one is successfully created now. It's provisioning. So I'm going to pause the video and come back. Once it is done, we'll continue. Okay, now the application load balancer has been created and it is active now. And let's go back to my Lambda function, and I want to show you here. If you see that resource-based policy statement has also been added, and the principle is elastic load balancing. You can see that it is, the elastic load balancer can trigger the Lambda function. So it has that effect allows, and the action is the Lambda invoke function. So our application load balancer can invoke the Lambda function that has been added here. And if you see here, and the trigger, it has been added here. Application load balancer can trigger the Lambda function. That's good, and we can go ahead now and create a public hosted zone on Route 53. And I have already created, and I already have a domain registered in Route 53. My domain is named awscommunitybuilder.com. And when I registered a domain in Route 53, it has also created a public hosted zone for me with these records, the name server and SOA. And for some reason, if you don't have a Route 53, if you haven't registered the domain on Route 53, if you are registered it elsewhere, and we need to create a public hosted zone here in AWS Route 53, and you need to make sure that name server record is matching for both the hosted zone and the domain that you have registered. Or for some reason you have registered a domain in Route 53 and you have deleted the public hosted zone for some reason, and then if you recreate a public hosted zone, and you will have a different set of name servers, it will change. So then it will not work. Like you cannot access the domain from the internet. So we need to again go ahead and make sure that name servers are matching. We need to update it, edit the records. So both both the name servers on the domain and the public hosted zone should match. Otherwise, you will not be able to access the domain from the internet. That's something that you need to remember. These are the name server records. So for me, it's matching here for my hosted zone on domain. I'm not going to go to the page where I have registered the domain here. So but you can just see that here. Okay, and if you want to create a hosted zone, you can just follow this process, like go to Route 53, go to hosted zones, and you need to click on create hosted zone. And here, this is the name of the domain that you want to route traffic for. So for me, like I would give here AWS communitybuilder.com, and then this is going to be a public hosted zone, and it's not a private one. And go ahead and create it. It's simple, so as simple as it is, and you can create your hosted zone. Once you are done, you need to go ahead and get the public certification for from the certificate manager. Let's go back to the console home, and let's go to certificate manager. Yeah, so currently I don't have any certificate, so I can go ahead and request one. When I can request a public certificate. Go next. I need to give fully qualified domain name. So my domain name is, like as I showed you, it is AWS communitybuilder.com. So I'm just going to give that here, and I'm going to add another name to this certificate, because we are going to create a HR application, if you remember, or we can have sales or admin or dev. So we don't know how to create individual ones. Instead, what I'm going to use, I'm going to do it star dot and the domain name. It's star.awscommunitybuilder.com. For the validation method, we can use DNS validation. That is the recommended procedure here. So if you have your domain registered in Route 53, and this is the recommended method, if you select this one, if you want it, it will go ahead and update the record for you. And I will show you here. Currently we have only two records, that is name server and SYA. So once I registered, you will see another entry record added here. I'll show you. But if you have the domain registered elsewhere, not on Route 53, so then you will need to select email validation and then follow the process listed in the email. You need to provide authorization and then add the record manually. But since I own the domain in Route 53, I'm going to use DNS validation. And I'm not going to change anything with the key algorithm. I'm just going to say request, and it's currently it's pending validation. We need to do one step here, like click on that certificate, and we need to create records in Route 53. So if as I said here, currently we have only two records, and the moment I create record in Route 53, it's going to create a record. I'll show you here. I'm going to create that, click on it, and then create records. It's done here. So once you go back to hosted zones and refresh it, see I have the third entry added here, new record. This is the record name, and it's a CNAME record type, and the value is added here. That's good. So now if you go back to certificate manager and go to certificates, it's already in from pending validation to issued state. So we have now a certificate, an AWS certificate manager, that we can use it for awscommunitybuilder.com or star.awscommunitybuilder.com. So far we have implemented this architecture. We have created a VPC, and we have created an internal application load balancer, and we have created the ENI for application load balancer on both the private subnets on two availability zones, US East 1A and US East 1B, and we have created a Lambda function and provided a permission for application load balancer to invoke the Lambda function. And we have also created a public hosted zone. Actually, I showed you how to create one, since I had already created one for me, and then I also showed you how to request a public certificate from AWS Certificate Manager for your hosted zone. I think that's we have implemented this one. Next, we need to go ahead and implement the architecture for AWS Verified Access. So this is the architecture that we are going to implement now. So in this, we have already done the part for Route 53 to create the hosted zone, public hosted zone, and also we have created a public certificate in AWS Certificate Manager. So we are going to implement the rest of the process, and I will show you how. Now first we need to go to Cognito, and we need to create user pool. Let's go to Cognito, and currently I don't have any user pool, so I'm going to go ahead and create one. And this is the Cognito user pool, and the Cognito user pool sign in options. So if you remember, we are planning to create two users for HR users with email validation. So I'm going to select email. We can select username and phone number. We can select all three also. Just for this demo, I'm going to select email. Click on next, and for the password policy, I'm just going to leave it as the default Cognito defaults. Now the password minimum length is 8 characters and contains at least one number and one special character, one uppercase letter and one lowercase letter. And so I'm going to just leave it with the Cognito defaults here. And for multi-factor authentication on a production environment, we should definitely have this one. It's recommended. But for this demo, I'm going to say no for multi-factor authentication to simplify the process here. I'm just going to show you that. And we can leave everything else default, and I'm going to go next. And so everything is good. Send email message, verify email. This looks good. Yeah. And so the required attributes based on the previous selections, it's email, and if you want, you can select the from the list here. And for the profile address, birth date, family name, we can do many things. I'm not going to select any of that here for the simplicity of the demo. In a production environment, you may want to select additional required attributes. Okay, let's go next. And for email provider, I'm going to select as send email with Cognito, and this is the default from email address. I'm not going to provide anything here for reply to. And for user pool name, I'm going to say that as my Cognito user pool. And we cannot change it once it is the user pool is created. Are fine with that? And we are going to use everything is good here, and we are going to enter application client name. So I'm going to select as my app client. I'm going to select as generate client secret here. I'm not going to change anything here. Okay, yeah, I think I can do one here. I'm going to allow custom authorization. Select that one here, and everything else looks good. And go next. And looks good here. Let's go ahead and create the user pool. Okay, now it is created, and let's go here and go to application app integration, and for the domain I'm going to create Cognito domain. So we need to provide a domain prefix. I'm going to select some random number and see, yeah, it's available, so I'm going to use this one. So I have created a Cognito domain, and click on my app client, and everything looks good here. And And I'm going to edit this section here, and I'm going to add callback URL. So this is nothing but like our application, like HR application. We need to have this one here. It's going to be hr.awscommunitybuilder.com. This is the domain, and this is the organization for HR organization that we are creating, and then this is the domain name, and we need to provide OAuth to IDP response. So we need to have this one here, and identity providers. Going to use Cognito user pool, and here authorization code grant. I'm going to select this one, and here I'm going to select OpenID, email, and profile. Good. For the custom scope, I'm going to we are not going to select anything for the custom scopes. Let's go ahead and save changes here, and yeah, it looks good. And okay, now let's go ahead and create Cognito users. Let's go back to user pool, and under users section I'm going to create user, and I'm not going to send an invitation for now. This is the demo, so I'm going to use HR user 1 at example.com. I'm going to create some fake email address, and I'm going to mark it as mark email address as verified. I'm going to set a temporary password. So I have created the temporary password for this user, and I'm going to create a user. I'm not saving it, and then let me create another one, and that's user 2 at example.com, and I'm not going to mark it as verified. So this is unverified user. I'm going to set the password again here, and create the user. So basically we have created two users, one as email verified and the other one is email not verified, if you see here for the email verified column. So HR user 1, for that one is email verified, and HR user 2 email is not verified here. And when they log in first time, it will force the user to change the password. That's good for now. And now let's go and create AWS Verified Access Trust Provider using Amazon Cognito. Before we go ahead and create AWS Verified Access Trust Provider, we need to copy the user pool ID, Cognito domain, client ID, and client secret. So here is the user pool ID. Let me copy it into the clipboard. And next we need to copy the Cognito domain. This is the Cognito domain. I have copied it to the clipboard. And also we need to copy the client ID and client secret. Creating app client, I'm copying the client ID. Next we need to copy the client secret. I have copied all four: user pool ID, Cognito domain, client ID, and client secret into my clipboard. Now we will use these details to create a verified access trust provider. Create the verified access trust provider, we need to go to VPC console. We have already created the VPC here. Yeah. And let's go down to verified access trust provider under AWS Verified Access, and then create verified access trust provider. I'm going to name it as you know I'm going to name it as verified access trust provider 1, and I'm going to use the same for the description. And here for the policy reference name, I'm going to name it as Cognito policy, and you need to remember this policy. We will use it later when we set the permissions. So this is a Cognito policy, and we are going to use user trust provider. We are not going to use a device trust provider for this demo. And for the user trust provider type, we are not using IAM Identity Center. Here we are going to use OpenID Connect. And for the issuer, and this is the syntax that you are supposed to provide here. It would be like the Cognito IDP and then the region and user pool ID. So that one would be here. So I have replaced this one with the domain. I'm in US East 1 region. It is Northern Virginia here, and this is my client user pool ID. And next for the authorization endpoint, and this is the syntax that you are going to follow. It's a Cognito domain /OAuth2/authorize. So I'm going to replace that Cognito domain that we have already copied to the clipboard. So this is it. And for token endpoint, it's going to be again Cognito domain /OAuth2/token. So I'm going to replace the Cognito domain here. And next for user endpoint, it is Cognito domain OAuth2/user info. I'm going to replace the Cognito domain here again with my Cognito domain. And this is it. On the client ID that we have already copied, I'm going to provide that one here. And for the client secret, I don't have any problem in showing the client secret here that we have copied. And from here, this is the client secret. By the time you see this demo, I'll have this Cognito user pool deleted, so not a problem. So I'm going to provide that client secret. For the scope, if you remember, we used email, OpenID, and profile. So I'm just going to provide that here. We need to separate it with space delimited list. And I'm not going to do anything. It's optional. Everything looks good. I'm going to create verified access trust provider, and it's created now. Now once this is created, next we need to create AWS Verified Access instance. So I'm under AWS Verified Access. Under that, I'm going to create AWS Verified Access instance. So create Verified Access instance. Click on it, and I'm going to name it as Verified Access instance 1. I'm going to use the same for the description. And I need to attach verified access trust provider here. So this is the one that we created in the previous step. We have created a verified access trust provider. I'm going to select that one, and I'm going to attach it with this instance. and create verified access instance. So it is done. We have created it. Next, we need to create AWS Verified Access group with basic policy. Go back to AWS Verified Access and click on Verified Access Groups. And click on Verified Access Group. I'm going to name it as Verified Access Group 1. I'm going to use the same here for the description, and we need to select the Verified Access instance that we have already created. I'm going to select that one here. And for the policy details, we're going to provide this policy. If you remember, when we created that AWS Verified Access Trust Provider, we have created a policy name. It's Cognito policy. So if you created something with some other name, you need to provide that policy reference name here properly. And then we are going to use that email verified is true. If the email verified is true, then it will provide access. If not, it will not be given access. If you remember, we created 2 users in Cognito user pool. The first user is HR user 1, and with we have verified email verified, selected that box as verified, and you can go back here, yeah, and go to user pool. And if you remember, we have created 2 users, HR user 1 and HR user 2, and email is verified for HR user 1, and we didn't select that option for HR user 2, so email is not verified, so we will not be given access for this user. But HR user 1 can access our application because it's email verified. That's the policy that we are setting right now, so that that for the policy that we created, Cognito policy, and then email verified is true. So that's good. So let's go ahead and create verified access group, and this has been created now. And the next step is we need to create verified access endpoint. Again, we need to go to AWS Verified Access and then click on Verified Access Endpoints, and then click on Create Verified Access Endpoint. I'm going to name it as Verified Access Endpoint 1, and I'm going to use the same here for the description. And Verified Access Group that we have already created, so I'm going to select that one. And for the application detail, for the application domain, we need to give our application that is the HR application that we can access it from the public internet. So we have our domain or hosted zone, that is awscommunitybuilder.com, and I'm going to go to VPC here, and I'm going to for the domain, I'm going to do that HR dot and the domain name or the public hosted zone. So this is the application for it's hr.awscommunitybuilder.com, and that domain certificate, I'm going to select the certificate that we have created in AWS Certificate Manager. If you remember, we have created certificate for both awscommunitybuilder.com and star.awscommunitybuilder.com. Since we have selected star.awscommunitybuilder.com, so here the HR group that we can select here. So instead of star, we have hr.awscommunitybuilder.com here. And for the attachment type, we're going to select VPC. For the security groups, we can select the default security group. I don't know which one is for my VPC. So let's go to console home and click on VPC here, and go to the security group. We have 4 security group and 2 for my the private VPC that I have created and two for my default VPC. So these two for the default VPC and these two security groups are for my my private VPC that I have created. So this is for my application load balancer security group. Let me sort it with a VPC ID. Yeah, that's good. So see this one. This is for my application load balancer and the same VPC ID, and this is the default security group. It's B93. Remember that one. Go back to this and security group and select B93. Yeah, that's the default security group for my VPC. I'm going to select that one, and endpoint domain prefix. I'm going to do that as HR. It's for a HR application, and the endpoint type is load balancer, and I'm going to select HTTP protocol and port 80, and we need to select the load balancer that we have created. This is my ALB for Lambda load balancer that we have already created, and for the subnet we are going to select both both the private subnets that we have created for this VPC and both the availability zone. So I selected that, and I'm going to leave everything else as default, and I'm going to create verified access endpoint. And now this is going to take some time. I'm going to pause the video and I'll come back once the status changed from pending to available. So it will take some time, maybe 10 to 15 minutes. I'm going to pause the video. Okay. Now the verified access endpoint is created and it is active now. So it took some time. So the final step is we need to update Amazon Route 53. Now that we have created all the required verified access resources, the final step is to associate the verified access endpoint domain with the Amazon Route 53 hosted zone record for access through a well-known and easy to remember application domain name. We need to create a CNAME record for this in Amazon Route 53 hosted zone. So first let's copy the endpoint domain here. So I clicked on verified access endpoints and it is active now, and I have copying the endpoint domain. Copy it to the clipboard, and let's go back to Route 53 here. And I'm on the AWS communitybuilder.com public hosted zone, and currently we have 3 records. These are the 2 records that we had in the initial name server and the SOA, and this record was added when we created the certificate manager, when we created the public certificate through the AWS certificate manager. Now we need to create the next record, new record, and we need to create the subdomain for our that matches our application domain. So in our case it is HR, and the record type is going to be CNAME record, and copy the endpoint that we have copied here, that endpoint domain whatever we copied here. So provide that one here and click on create record. So we have completed all the steps now. Now we need to go ahead and test the application. Okay. Now to test our application, I'm going to open a private window. I'm going to open a new private window and type in the URL, that is https://hr.awscommunitybuilder.com. Now let's try to log in using our HR user 1. And we need to change the password. It worked. Now we are logged in to the HR application. Welcome to the HR application. This is the simple web application that is hosted in our Lambda function. And HR user 1, if you remember, that has access like email verified. For HR user 2, the email is not verified. So I'm going to go ahead and close this one and open another private window, and this time I'm going to log in using HR user 2. If you remember, we don't have email verified for HR user 2. Let's see if it works. It shouldn't actually. First login, we need to change the password. Yep, as expected, it is not working. It is unauthorized. We have tested our application. If you go back to our Cognito user, if you have HR user 1, the email is verified, and for HR user 2, email is not verified. And if you remember, when we set up our verified access trust provider, we set a policy, Cognito policy, where it will allow access only for the email verified users, not for the one that is not. If the email is not verified, then it will not provide access. Thank you, everyone. And this concludes the demo on protecting applications with Amazon Verified Access with Cognito as the user trust provider without VPN. If you like this video, please subscribe to my channel, like this video and comment. And I will see you on the next one. Thank you. Bye.